All right, so I'm Andrew,
I'm Isaac.
I'm Tyler.
I'm Nick.
and we did our project over days hunted per year.
Our model was y equals b naught plus b1 all the way through with an error at the end. But our x1 was gender of the individual, x2 was highest level of education completed, x3 was if the individual has ever fished, x4 was relationship status of the individual, x5 is race of individual, x6 was employment status of individual, x7 was weight of individual, and x8 was retirement status.
All right, so the variables specifically that we use in the model were our y variable was days hunted, and that was measured in days per year. The gender of the individual, we had 2 units we made into a dummy variable, so 1 was male and 2 was female, and we expected to decrease. And what that means is that we expected males to have more hunting days compared to women.
For the highest level of education completed, 1 through 12 would simply be the grade level. 13 would be some college, 14 is bachelor's degree, 15 is some graduate school, 16 master's degree, 17 some doctorate education, and then 18 is a full doctorate degree. And we would expect a decrease, so that means with an increase in education, you would expect the hunt days per year to decrease.
And then for people that ever fished, we marked 1 as have fished and 0 have not fished. And people who have not fished would have a decrease, and people that have fished would expect an increase.
On the relationship status of the individual, we expected people who were married. 1 was married, 2 was widowed, 3 was divorced, 4 was separated, and 5 was never married. And we expected that as they grew further away from married, we expected it to have more hunting days.
And so then with the race of the individual, we set 1 equal to white, 2 black, 3 American Indian, 4 Asian, and 5 Hawaiian. And we expected that to decrease. And what that means is that the farther it got away from the white race, it would show less days hunted per year.
And for employment status of the individual, 1 would be have a job and 2 would be no job. And we would expect an increase in hunt days per year for the one that would not have a job.
And then for weight of an individual, we did it in kilograms, and the more people weighed, we would expect a decrease in hunt days.
For retirement status, we had 1 equals retired, 2 going to school, 3 keeping house, and 4 something else. And as the expected sign was decreased. So as they were retired, we expected them to have more time in order to be able to hunt.
And we got the data from Data Ferret, and Data Ferret got the data from National Survey of Fishing, Hunting, and Wildlife Associated Recreation in 2006, and it had 121,465 participants.
And so then with our descriptive statistics with the mean and standard deviation, some of the specifics that we found interesting was that gender, based on the individuals we had a majority being female, because earlier in the slides we mentioned that 1 was male, 2 was female, and this leans more toward the females. Another one we found interesting was the ever fished. We found that our group of individuals, more of them did not fish compared to the ones that did fish. And then the last one we found pretty interesting was the employment mean. It showed that more people were employed compared to those that weren't. And so then our regression model, we found our B's for our data, and we found that gender had a negative 0.265 correlation.
School had a negative 0.013 correlation.
People who fished had a positive 0.266 correlation.
Marital had a negative 0.016 correlation.
Race had a negative 0.039 correlation.
Job had a positive 0.114 correlation.
And for per weight, there was barely any correlation.
Retire had a positive 0.018, so a 1.8% correlation.